So that's part of the assignment 2. And here I provide the data and already identified the outliers by using 1.5 times the interquartile range. So you should have that one in your assignment 2. So here, for our regression analysis, our dependent variable is the average price. So we have daily average price. And our independent variable will be the percentage of energy output by different field type. So doing regression analysis, we want to see the association between the percentage of energy output of a specific field type and with the average price. So for example, I can translate that question as, so whether this association with the percentage coal and energy price. So whether we can see when the energy output seeing more output from coal, and that's part kind of the fossil, energy, and then we probably will see the energy price, that the daily energy price will be increased or decreased. So we want to see whether there's a positive or negative impact or positive negative association. So that's the purpose of our regression analysis. So in this learning module, when I introduce regression analysis, I also introduce some assumptions of regression analysis. So we have to handle those assumptions before we proceed with the analysis. So for example, first one of the assumptions of linear regression is the observation is independent from each other. So that will be a case, for example, you want to test the impact of a certain medicine, right? And then you randomly recruit some patients and from different state, in different age group or different gender, so and so. And you have the observations of those patients. So when you analyze the data, and you don't need to worry about the data is independent on each other because that's a random sample and there's no relationship between those patient or subject. But sometimes we will have. So for example, if you measure a patient and day by day, so first day, second day, third day, and multiple days, and then there's certain relationship between the observations because that's all from one patient. So you need to carefully check the data or use different method. So here we have the time series analysis data, time series data, and time series data is highly dependent on each other. So that's when we talk about time series data, and there's a famous term called a random walk. So it's like, so the next day price can be random, either higher or lower, but it's still and somehow within certain range of previous data. So for example, you have this price, let's say 15 or 16, and next day price will be within certain range of 16. And it's very unlikely to see next day price is totally independent from the previous day and suddenly jump to 100 or 200. So that's never the case. So that's pattern is more apparent when we look at stock price data. So stock price data, it can never be like not dependent on previous day or relevant previous days. So given that situation, and we do have the observation dependent on each other. So that actually is part of one of the attributes of time series data. So later when we introduce the time series analysis, and we need to handle it, and we will talk about that. So given we use time series data, and data is not independent from each other, and we need to do something. But before that, you see we have outliers, right? So remember, and we use the interquartile and to handle the outliers, and we have outliers. So in that case, if we want our model to be more reliable and have high statistical power, so that means our model can explain the much variance of the data. If you have outliers, and the outlier can influence the model, and then so the model cannot be as reliable as when you're removing all the outliers. So in most of the case, and you can remove outliers and just focus on construct a model and fit the data with the majority of data. Of course, certain time you may have a big portion of outliers, and say like 20%. And then it also makes sense. You need to look at the pattern and investigate the 20%. So you can use one model and to predict the majority, not outliers, say 80%. But you can also develop an additional model or use different method and to investigate the outliers. So if it's account a big portion of your data. So here, first step, I'm going to remove the outliers. So in Excel, it's quite easy. So once you have outliers identified, and you can use a filter, and I'm going to put it in order. So here, and I put the data in order, and then I can simply uncheck, and Y means outliers. So here I have the data observation, not outliers. So next, I'm going to copy paste. So that's also another good practice I want you to keep in mind. So even you are going to maybe filter the data, maybe you want to add a change certain data field, but still try to copy paste to a new spreadsheet, because you don't want to make some change and later you figure out, oh, I made a mistake. So let me go back to the original data. So sometimes it will be too late. You already did a lot of changes. So it's a good practice. Here I filter the data, not outliers, but I'm not going to just delete those outliers here. Instead, I'm going to just copy paste the data I need here. So you can see now from among the 331 data points, now I have 691 data points. So I'm going to copy and paste on the new sheet. Okay. So here is the data I'm going to analyze. So outlier handle, and now it's let's handle the dependency. So data is a time series data, and it's more likely and showing the dependency between observations. And we also call it auto correlation. So the previous day, today's data point is correlated to previous day data points. So it's auto correlation of the time series data. So in that case, there's a certain way we can handle the auto correlation or dependence between the data points. So one easy way is use a differentiating. So just to calculate the difference of today and from previous day. Right? So here I'm going to create a new column called price. So for first day, there's no previous day, and we can calculate the difference. So here we can just manually input 0. So there's no previous day. So the change will be 0. But for the second day, and we know, so we can calculate data with the second day price and minus previous day price. So here, second data point, we got 3.11. So we can simply double click and use the Excel autofill and to calculate all the difference. So with difference, and it's more likely the data won't dependently correlated with the previous one. When we use time series analysis, and we may calculate use a certain way to, for example, use a partial autocorrelation function and to measure or to visualize. So whether we use so when I calculate, so day 2 minus day 1, and we call it leg 1. And sometimes you need to use the day 2, day 3 minus day 1, or day 4 minus day 1. So in that case, it's called leg 1, leg 2, leg 3, or leg 4. So sometimes you use a leg 3 or leg 4 and to result the data not correlated with each other. But for this assignment, let's just use leg 1. And we can also visualize once we have the leg 1. So we have the time difference, we have the value difference. And one easy way we can visualize and see whether data is still showing some trend or seasonality pattern. Right? So either way, we can just visualize. This time, I'm not going to create a chart, and I will take advantage of the analyzed data. So I click Analyze Data, and here you can see the chart. So it seems like there's no some apparent pattern or trend. So I will assume, so that solves the autocorrelation problem or the dependency problem. So I'm going to use this like one price difference and to do the regression analysis. And you can also visualize the distribution of this data set. So it looks like it's a really good bell shape. So then we may solve another problem, right? Another assumption. So the second assumption is the data should be normal distributed, the pattern, right? So one way we can use is simply use the figure histogram and to see whether the data is somehow showing bell shape. So it looks like pretty good to me. And for normal distribution, and as I introduced the last time, and we can also use other statistics. So let's do it. So here, remember, we are going to go to data and data analysis. So we can get some key statistics and to figure out whether the price difference is normally distributed or not. So we use descriptive statistics. We click OK, and then the data range will be M1 and M691. Okay, so we have data range label in the first row, and we use a summary statistics, and we click OK, and from the result you can see normal distribution. See this one, skewness. Right? So remember, we introduced the skewness. If it's within 0.5, yeah, it's okay. So we seldom get the perfectly normal distribution pattern that will be skewness 0. Yeah, we seldom get that one from real case. So less than 0.5, it's kind of acceptable. So that's our concern on the normal distribution assumption. The second one, and the corpses, so which is whether we have like extreme outliers. So here's the data, the value is less than 3. So that means we don't have extremely positive outliers. So that's how we also solve another concern. Now we can go back data. So the data already solved 2 assumptions. So one is the data is not dependent. And here we use the price difference or use a lag, like 1, and to solve the dependence of observations. The second one is data should be normally distributed. So we visualize with the bell shape, with a histogram, and we also use the skewness as indicator and to track this assumption satisfied. So the third one, since we are going to use multiple regression analysis, and the assumption of multiple regression analysis is those independent variables are not correlated to each other. So the reason for that is if some independent variable are correlated with each other, and that will create some we call the confound effect. So that means some impact will pass through another variable, and so in another variable also have like a significant impact. So give an example. So if the percentage of coal and the percentage of gas are highly correlated with each other. So when coal is increase and percent of gas increase, when coal is decrease and percent of gas also decrease. So when those two highly correlated, and if we run multiple regression on the price, and when we see the percentage of coal and showing significant impact on the price, and we will likely also see and percentage of gas have significant impact on the price. But actually, so the percentage of gas may not significantly associated with price. It's just because the impact of the correlation with the percentage of coal and pass through and get impact on the price. Right? So that's why we need to be careful when we do multiple regression analysis, and we need to check the correlation between the independent variables, because we don't want to misinterpret certain impact. And actually, it's if the variables stand alone, and there's no impact. It's just a certain other variables and pass through the impact on the dependent variable. Okay, so if no, let's test. So whether those variable, independent variable are correlated. So I guess you still remember as part of your assignment tool, so you can use Excel and to do correlation. So again, we will click data analysis and we'll find correlation. And we click OK, and we need to give the range. So here, our range will be from percentage co to percent win. So that's B1 to J1. Okay, so we're good. And we have label in first row and okay. So here's the result. So let's also be a little bit generous with the cutoff point. So normally, if you have correlation coefficient greater than 0.5, and you can see those two variables correlated. If it's a 0.8, it's a strong correlation. So let's use a 0.5 and to add cutoff point. So above 0.5, highly correlated. Below, and let's accept and include in the model. So here we have 1. So percentage of coal and percentage gas is correlated with, let me highlight. So with a coefficient greater than 0.5. So then we screen others. And here we find another one. So percentage of gas with a percentage other negatively correlated because less than negative 0.5. So there's another one. And then, so let's look at others. And we don't see others. And either greater than 0.5 or less than negative 0.5. So we just identify 2. And look at the 2. It's all related to percentage of gas. Right? So one is the gas and the coal. Another is the gas and the other. So then when we decide how to construct the multiple regression model, and we can use remove gas and from our model. So use others because the gas is highly correlated with coal and percentage others, and highly will be influence the impact of those two variables. So then we are going to use a multiple regression, but remove percentage gas from that model. And we are still interested in how's the impact of a percentage gas. And in this case, we are going to run a simple regression, and which means there's only one independent variable and use a percentage gas. So we are going to run 2 regressions for this assignment. Okay, so if no, so let's do regression analysis. So let's do the first one, multiple regression analysis. So things in Excel, when you select input for dependent variable and the independent variable, and you need to highlight the range. So here, we don't want to include percentage of gas. So we cannot use this way to highlight the data range. So what we need to do is we need to just temporarily move gas to another column. So I'm going to copy and paste gas here, and then I'm going to delete gas, and then you can see gas is here on all others and connect each other. So now we can do the regression analysis. So we click data analysis, and find regression. So we have regression here. So click OK, and Y is our dependent variable or outcome. Okay? So that is our price difference. So that will be M1. Yeah, so that's right. So for X range, so X will be independent variable of our predictors. So we need to select range. So that will be from the percentage coal to percent wind. So select the range. And so we have label in the first row. And confidence level is where you can change. So what's the significant level? In the assignment, I define 0.05. Right? So that means you need to have 95% confidence level. So keep it. So we can keep it 95. And sometimes people will say, I want to treat 0.01 as significant, and then your confidence level will be 99%. And then you can change here to 95%. Right? So we are fine with the 95% with confidence level 0.05. Okay, so that's it. Yeah, you can do more. So actually, you can create a residue, and you can also create a line fit plot, right? So yeah, so let me select a line fit plot. So click OK, and we have this output. So here is an analysis result. Among all the indicators, and you need to interpret coefficient, p-value, and R-square. Right? So let's start with R-square. So R-square is 0.08, or kind of 9%. So how you interpret the R-square? You can view the video. So I can briefly introduce here. So R-square present the degree your model can explain the variance of the outcome. So you see the price increase, decrease, and showing the variance. And you build this regression model and try to predict or analyze the trend of the price. And then given our R-square just 0.09, so that means our model can only explain 9% variance of our outcomes. So we don't have a really reliable model, but it's understandable. So we are analyzing energy price. And you know, for energy price, for stock price, and there are so many environmental factors. For example, inflation, for example, labor cost, interest rate, so and so. So it's very likely we don't have really, good model and have a really high R-square. So I have really high R-square. So here is the fact. Our model can only explain 9% of variance of outcomes.